Welcome to another GCBASIC video. This is looking at the Blockly alpha release. That's the release I'm going to put out there and let people really kick the tires on it. What's Blockly? So Blockly is a new paradigm of programming for GCBASIC. It's long been promised. I did write about this over a year ago, saying I would do this. I finally got to it, and it's just introducing a new drag and drop paradigm for programming. It's not my invention. It was originally done by Google and MIT. They kicked all this off, and it really is just drawing upon what they've established. So historically, we've had a graphical user interface inside of GCBASIC, and this is due to replace it, and it looks something like this. I've got pieces of code on the left and right hand side with a logo in the middle. The logo automatically disappears. In terms of scope, there is no reason why any part of the scope of GCBASIC cannot be included. This baseline gives us the functionality, the essential functionality we need. Once we get some deeper set of requirements in terms of the control mechanisms, then we'll add more. But you've got the variables, loops, conditionals, mathematics, subroutines, and direct hardware interaction already. That's already there. In terms of current development and the future, it's really down to people using this, driving that requirement. No point to keep putting things in if it's not going to be used. Continuous development, it's up on GitHub. There's a URL inside of this post, and you can try it yourself by going to this URL up on the GC Basic website. So I'll just take a copy of that, and I'm going to open up a new incognito. Now, why am I doing that? Because you get the full experience. Okay, here we go. So first thing you're going to see, I will zoom in on that a little bit so that you can see it, is you're going to get a sort of change note pops up. You can see a change note there. Let me just bring that in. Change note. You have to OK that to get rid of it. But each time I do a major change, or we will revise this change note will get shown to you. Then at least you know what's happening. Once you OK it, you're sort of done. Now, what you might not have seen in the background, whilst that was loading, you get the logo come up, and then after so many seconds, that disappears, gets out of your way. Okay, it just trademarks it. Okay, gives you that feeling of what's going on. So, what are we looking at? On the left-hand side, we have program logic and chip definition, and on the right-hand side, I put some constants, my global variables, and the subroutine. And you can fill a massive page. You can zoom in and zoom out on this stuff. On the right, left, you can bring it back into focus. You can move it about. I mean, this could be absolutely huge. So you can drag this about, very nice, and you can zoom into whatever function you're working on or capability you're working on. So we can generate code. We can move the desktop around. This is called the workspace. If I put the workspace over there, I can bring up the what's it called, the output window. Let me just drag it slowly. I'm going to put this output window at the top of my screen here. Why am I putting it up there? Because I'm going to generate some code in a second. And once it's there, I'm just going to drag that down so we can see all the code. Okay. Now, top left-hand corner is generate code. I'm not going to zoom in. The moment that you press that the first time, it just asks for your name. Now, it's not storing your in a cookie or anything, in your name in a cookie. It's just so that inside of the source code, it's just generated on the right-hand side in that box. It's got your name in there. So if I zoom in on that, we can see that it's generated a whole series of code. There we go. You should be able to see that. I might have to zoom in a bit further for you. Let me, this a bit more. You can see it's generated a load of code, and that code will work. It should work. If I copy that, and I go and put it in a IDE, one of our IDEs, I can go Control A, Control V, and it's actually inside of that IDE now. Control A, Control V, I've just done that. I'll just do it for you again. Control A. That just deletes everything. Control V, put it in. Function key F6. And it will compile it. There are lots of ways of compiling, but that's just compiled it. And I'm going to put that inside of this very simple, that's not insulting. I'm going to put this inside of a emulator, and that emulator will then load that code in because it's suitable for that configuration. And that's what we're going to recreate in a moment. Is it's doing what the code said, and we'll prove that in a minute. So let's write some code. Let's zoom out to my full desktop so you can see it, and we'll look at Blockly sitting there in all its glory. I will zoom in when required. I am going to press new project. I've done it. I'm going to pull in a chip. So the first thing I do is set up a chip, and I'm going to put that somewhere on my desktop. I'll leave it there. And there's a little box, and I'll zoom in on this so you can see it. There's a little box on that, a little icon, and I can type into that little box the chip 16F877A, and the moment that you need to confirm it, it gets rid of that little type in box. Quick way of doing things. Now, I've already set up this particular piece of hardware, the simulator, and I've got some constants, and I can pull those constants in. I've already exported them, and they're called LCD IO4. And the moment I double click that, it puts that set of constants in my program, and that sets up, if I expand it for you, all the constants to set up the hardware. It's brilliant. Okay, that just works. So now what I've got, if I collapse that, what I've got is chip selected, all the constants to set up the LCD. So what I want to do now is add in, I'll just put that there. What I want to do now is add in the hello world. Obviously, everyone needs to do hello world. So text, and we can just say hello world. Now you might think that won't work, but it will generate code, because if I press the top right generate code, and then we look at the output from the code we were looking at earlier on, I'll look at that there for you. It's generated a fully working program. I can now copy that. I can pop out into the IDE, compile that up, and we'll see if it works. Control A, delete everything, press function key F6, and we'll load that into the emulator, and we will see hello world. It's done exactly as it should have done. Let's make it more complicated. We're going to put this hello world, right hand mouse button, I deleted it, I could have dragged it to the dustbin. But let me zoom in for you so that you can see it. Let's create a loop, basic loop, do something forever. I'll put that there. Do a loop forever. And what I'm going to do is I'm going to bring in another loop, for next loop, and then we're going to show that for next loop operating. Why is it red? Because you need to put a variable in it. It needs a variable. There are no variables defined. So you can pull out myvar, pull it out. You can put that in there. Rename that. The first thing you should always do is rename variables. Don't rename the variable as. It's just a bit out of view here. So let me just move the screen a little bit so you can see it. I'm just going to type in my loop var. Now it's put me back on. It's put me back where I was. The little pop-ups disappear. I can drag this red my loop var. That's the definition of it. And that's sort of important. So I'll leave that hanging up the top. Okay, let me put some numbers in. I'm going to say count from 0 to 254, 255 maybe. Click on it, 255. Now we're going to print out to the LCD, so I am going to say print it. And then I can click in there and I can type in my loop var, and it will print my loop var on the LCD. I can say to it, let's clear the screen. What won't happen is we won't see it because it will happen so fast. But what I do need is a wait, and I can say, I'll put a wait right in the middle of those two. And I'm going to say wait for 500 milliseconds. So I can select milliseconds. Now, you might decide that it would be better to have milliseconds as a default. Let me know, because these defaults are defaults. You can have what you like, but we just need to agree. So now it says, do forever, do a loop forever. There's a for next loop. So for my loop equals 0 to 255, put that on the screen, wait half a second, and clear the screen. Generate code. Let's have a look on the code. And over here on the right hand side, it has defined our variable for us. It's initialized it, and it set it my loop to 0 to 255, and it's done the piece it should have done. Let's copy that out. Let's compile it and see what it says. Into the IDE, Control V, function key F6. Now, as I've said in the posts, if you guys want to integrate this so it does it all automatically, please do. Don't let me stop you. I'm never going to stop anyone from doing anything, all right? Okay. It's just that I'm not going to do it tomorrow. Right, recent file, load in that file. And believe it or not, it's doing what it said in Blockly. So it's doing exactly what was defined. GCBASIC has been called. It's going through the standard routines. And if I speed up the simulator, only that we can see on 256 lot, it's still going to take a long time to show 256, isn't it? Yeah. It will go through 255. Is it 255? Let's have a look what was in my code. Look in Blockly. Oh, it's 255. It will just loop around when it gets to there, and because that's a function of integer maths, not Blockly. So Blockly generates code. I just want to see that loop, that's all. Great, it's done it. I'll stop that emulator. Yeah, I've just stopped it. So what else can you do? You can do messes. You can do logic. You can say, right, if then else. You've got other calculations, if something and something, not something, and just out of view, if true. So you can do an if, you can say, right, let's have a look in here. If something, right? So then we can say, let me do some math here, hook that into there. I'm going to take a copy of my loop. Oops, what did I do then? I did a comment. I don't know what that's doing there. Let's put that up there. I'm going to put if my loop equals a number, and I'll say 10. I'm going to do something. I'm going to do something different. Now, in here, I put the number 10. And in here, look, it can be not equals to, etc., etc. All the standard things are there listed just out of sight. So I can now say, all right, if it's 10, do something. But let me just pull that out and we'll just destroy all this lot. So normally it's going to do print my loop and then duplicate that. I can put that in there. And if it's 10, I'm going to print out 10. But I'm just going to move my weight, put that there, put that in there, and I've now changed the complete logic program. It says, if my loop equals 10, print the number 10. Oh, that's a bit loopy, isn't it? Yeah. We're going to say hello, function key F6 to generate the code. And I guarantee you that if you look over in the source window, which we can look, it says If my loop equals 10, then print hello, else print my loop var. It's going to do it. I don't even have to go and test it. It will generate valid code. Notice all the indents are sorted for you. That's automatically added in and sort of calculated and formatted. So what you're seeing here is a comprehensive tool set that allows you to do quite a lot of stuff. So we'll have a quick look at the functionality. In terms of, we've got logic, I've shown you that. In terms of maths, you can do calculations, is numbers, is it odd, you can do modulus. And again, these are just the basics I put in. Variables, you can create variables, obviously. You've seen that. Lots of different loops. And why was that red? It was red because it needs a variable to make it work. And once you put it in there, it goes green. Text, you can print text out, or you can print out constants and whatever. Subroutines, let's create a subroutine now. I'm going to create a subroutine and it's going to be called my subroutine. And I'm just going to put it here on the screen just to keep it nice and simple. And in my subroutine, I'm going to call it, and all it's going to do is say hello, okay? Because I haven't got time. How do I call a subroutine? I sort of drag this out and I give it the same name. My subroutine, I'm going to say call my subroutine. And you can call my subroutine with parameters and all manner of things. So now, rather than do the hello print inside of that if then statement, I'm going to generate the code and we'll have a look what it's generated. All right, it now says call my subroutine, and it's generated the subroutine that you've just written. It's done it. It will work. You just take that into, you can take that into, why don't we just do it? Take it into the IDE, Control V. That is the program, because there's the subroutine. You can't see it. I'll just zoom out for you. Function key F6. Bring up the emulator. Zoom in on the emulator for you. I'm just going to load that file in. And we're going to see things happen. It's doing what it should be doing. What is it? Let me just see if that's doing what I thought it. If my where's my function gone? Why didn't it stop? I'm going to put a little wait in for us. I don't like debugging things live. Wait for. Probably did it and we just didn't see it. Print hello. That's a bit weird. Never mind. I'll put that one like that. Just change the source code. I'm just going to take a copy of it. Compile that up. I wonder if I loaded the program. Hello, waits for 5 seconds and carries on. Let's just see that again. I'm running the processor at 64 megahertz, not 20, by the way. It's doing what it said it was going to do on the box. So with that, you can do some extremely complex things. And you can do, so I've called a subroutine, fantastic. You can also do other types of iterations in there. You can put for next loops inside of for next loops and loops inside of loops. It's not hard. So if you pull out a loop here and you say, I want a repeat loop, I want it one time, and I can drop that piece of code inside of here, I can then attach it into here. So I've now essentially got a wasted space, but let's just generate the code and see what it does over in the source. It's done it's doing everything for you. It's doing your formatting, it's doing the layout, it's generating what should be good code. We were looking at what else you can do in here. If I zoom in on that level so you can see it, you've got containers, which I've shown you, containers of constants, containers of variables. There'll be others as we move along. Commands, I haven't implemented many because I don't know what to implement. The basic LCD is clear the screen. If you want the rest, it's very simple to add them. Wait, a very simple set of weights. And the weight is intelligent. I'll show you the weight itself. There's a weight here. It's on the screen. If I just zoom in slightly. Here's a weight. I'll pull it out so you can see it. It has a constant that you can put in, or you can put a variable in. So if I say duplicate this variable, oh, it duplicated the whole block, which is not what I wanted. I'm just going to go and put that lot in the bin. It's gone. I can drop that inside of here. And now the 500 on the left there is now grayed out. It's not valid. It's now going to take the constants of my loop and use that. You can do some extremely complex things that just would be too hard to explain inside of the textually based program. In terms of maths, you can also drop maths into things. So you can say, rather than use, oh, I just destroyed my weight, didn't I? I'll duplicate that weight. Then we have a weight to put back in here somewhere. It was in there. I can actually calculate a number. I can say, give me two numbers, add them together. So I could take a copy of this number. I'm doing this. I'm copying a whole block, which I shouldn't be doing. I've taken that out of there. I probably, oh, there you go. A bit of a pointless exercise there. Look, just delete that block. And whilst it's operating, it would add 10 to 10 and use that as a variable. It would generate source code, etc. Bit pointless. So what you might want to do is just say, oh, I've done my test, I've done the calculations. If I disable it, it now, you can disable code. You don't delete it or comment it out. It just deletes it. Finally, if I wanted to put a comment in here, so I'd add a comment of this main program. I will show you what happens. You can add comments into blocks, generate your source code. Looking that's happened on the source code. It's now put in here, right in the middle of here, exactly where it should have done it, main program. So it will take your comments from the blockly and put it into your source code. This is the alpha release. What's important about the alpha release is kick the tires. Does it work? What else is required? There is no basic input and output yet. How should that work? Do we want to pull in all the configurations, or do we want to use these constant blocks to say, no, for a particular chip, pull in a constant block? Where does that data come from? The essential tool works. If at some point there's a discussion that says we want to automatically generate the code and program it in one go, that is feasible, not hard, but someone needs to have a requirement before we go and do it. This is the basis. With that, I'm just going to press reset. Now, if you wanted to save something, I ought to show you that. If you wanted to save something, you literally take the buttons at the top. Let's look at those. You can import blocks. We looked at that. We can save the file. We can save the file, and it gives you put your file name in, and then therefore you can reload that file. So if I wanted to call this demo1.xml, I can then, it will save it to my desktop, which is fine. I am just going to say new project, and then I'm going to open that file. The intent is it puts it back as it was. After 10 seconds, the cow disappears. What else is in there? You can export code. So if you created a whole series of constants and you said, right, I want to put those away, you can just export. And that export means you can import. Very good. Now, so you can save things, import and export. Export code. It will actually save the GCB file for you called generated. I've been really silly doing all this. In the demonstration here, I should have done this. There's an enhancement. There's an enhancement that's already just come to me that someone can propose. So basically what that is doing, it's just updated the source code. It's fine. Right, well, you can reset the whole workspace. You can turn the grid on and off. There's a little grid for hooking things up to, which is great. And then there's open README at the moment, which shows you the README that we started with. After 5 seconds, you can press OK to get rid of it. And with that, I'm going to press reset. Now, let's cut the things that you cannot do. I'll zoom out completely. You cannot press function key F5. That is so tied up with GCBASIC. If you refreshed the browser, you'd lose your work. So that's been disabled. If you want to refresh things, you have to do a reload this page. Function key F6, same as GCBASIC, generates source code. So if I clear the source code, press function key F6, all our tools, function key F6 generates code. So there we go, it's generated code. If I do the reload, it will put me back to the demo. That's a complete insight of half an hour. Sorry about the delay. It's a big project. Alpha release is ready. It's out there. Go kick the tires. Enjoy.